Hi everyone, welcome to Acharya Mathematics. It always seems impossible until you visit Acharya Mathematics. I hope you have seen my previous videos. In case you are not seen, please go through it. Dear students, in today's session we discuss graphs of trigonometric functions. Then what do you mean by graphs? So here we discuss behaviorness of individual trigonometric functions. We term as graphs of trigonometric functions. Let us discuss graphs of sine and cosecant functions. So here we discuss one by one. To discuss graph of sine function, we take it as y equals sin x. X represents an angle. For each angle, we get corresponding values. When x equals 0, y becomes 0. When x equals 30 degree, when x is equal to 30 degree, y equals half. When x equals 90 degree, y is 1. When x equals 180 degree, y equals 0. When x equals 270 degree, y equals minus 1. When x equals 360 degree, y equals 0. Similarly, here we observe that when x equals 0, y is not defined. When x is equal to 30 degree, y equals 2. Is it right? When x equals 90 degree, cosecant x is 1. When x is equal to 180 degree, y is not defined. When x is equal to 270 degree, y is minus 1. When x is equal to 360 degree, y is not defined. With this information, now we plot the graph. Here to plot the graph, we consider the coordinate plane and we mark the equal intervals of pi by 2. I have taken as equal interval pi by 2, pi by 2, pi by 2, pi by 2, pi by 2 like this. So here when x equals 0, y becomes 0. That is the point 0, comma 0 here. Next, when x is equal to 30 degree, we get half. It may be approximately half. Okay, so here next when x is equal to 90 degree, so y is 1. I have marked the real numbers on y axis. I have taken this distance as 1 and this is minus 1. Okay, so here when x is equal to 90 degree, y becomes 1. When x is equal to pi degree, y becomes 0. Okay, so then next when x is equal to 3 pi by 2, y equals 0. When x is equal to 2 pi, y equals 0. After joining these points, we get a shape of the y equals sin x in the interval 0 to 2 pi. I hope you got it. Again, in the same interval of 2 pi, the curve repeats the same shape. Okay, so here hence we say that sine function is periodic function in the interval 2 pi. Okay, so here this white colored curve represents the graph of y equals sin x. When we observe y equals cosecant, so when x is equal to 0, y equals cosecant 0. Cosecant 0 is not defined in the sense that here the cosecant curve have no point on the y axis. When x is equal to 30 degree, y equals cosecant 30. Cosecant 30 is 2. It may be approximately here. Okay. Next, when x is equal to 90 degree, y becomes 1. Again, this is 1. Okay. Next, when x is equal to 180 degree, again it is not defined. So here, this is a point and this is also a point. So after joining these points, we get a shape like this. Next, when x is equal to 270 degree, y equals minus 1. Y minus 1 comes here. Y equals minus comes below the x axis. This is y minus 1. And here at 180 it is not defined. Okay. Next at 2 pi 360 degree, again it is not defined. Therefore the shape of the cosecant x like this. So here there is a smooth curve. So you observe here in the interval 0 to 2 pi, the blue color curve represents the curve y equals cosecant x. The same curve repeats in the next in the interval 2 pi. Therefore, here we say that cosecant function is also a periodic function with the period 2 pi. Sine function and cosine function are periodic function with the period 2 pi. So we say that sine of 2 pi plus x equals sine x. Next, cosecant of 2 pi plus x equals cosecant x. And you note that here, for any value of x, the sine function, the sine curve oscillating between minus 1 to 1. Therefore, we say that sine x is oscillating between minus 1 to 1. Whereas cosecant x do not lie in the interval minus 1 to 1. It lies outside the interval plus 1 and minus 1. Therefore, we say that is cosecant x is always greater than or equal to 1, or cosecant x is less than or equal to minus 1. Okay, so here sine curve is a continuous curve, whereas cosecant is a discontinuous curve. This is about the graphs of sine and cosecant functions. I hope all of you understood. It is right. Graphs of sine and cosecant function to trace out the curves. First we find the points satisfying the equation y equals cos x and y equals secant x. Here we know that when x equals 0, y is 1. When x equals 60, y equals half. When x equals 90, y equals 0. When x equals 180, y equals minus 1. When x equals 270, y equals 0. When x equals 360, y equals 1. So here I have considered a coordinate plane. So this is horizontal line represents x-axis and vertical line representing y-axis. On the x-axis, I have taken equal intervals of pi by 2. So this is 0, 0, 1 pi by 2, 2 pi by 2 is pi, 3 pi by 2, 4 pi by 2, that is 2 pi, 5 pi by 2, 6 pi by 2, 6 pi by 2 is 3 pi, 7 pi by 2, 8 pi by 2, that is equal to 4 pi. Is it right? Next I am going to mark the points here. When x is equal to 0, y equals 1. When x equals 0, y equals 1. When x equals 60 degree, approximately 26 degree, so it will be it is half. Y is equal to half. Okay. Next, when x is equal to 2, when x is equal to 90, y equals 0. So this is the point. When x is equal to 180 degree, that is y equals minus 1. It comes below the x-axis. It comes below the x-axis. Is it right? When x is equal to 270, y equals 0. So this point. Okay. So this point. And next, when x is equal to 360 degree, y equals 1. Okay. So here, after joining all these points, we get a shape of the curve y equals cos x in the interval 0 to pi. Again we move on. Again increasing the angles 5 pi by 2, 3 pi, 7 pi by 2, 4 pi. Again the curve repeats the same curve. The curve repeats the same shape in the interval. Again 2 pi interval. So here it means that here the shape of the curve y equals cos x repeats in the interval 2 pi. So hence we say that cos x is a periodic function in the interval 2 pi. Okay. Next, let us move to the y equals secant x. When x is equal to 0, y equals 1. When x equals 60 degree, y equals 2, approximately it is here 2. Next, when x equals 90 degree, it is not defined. Not defined means that when x is equal to 0, secant is when x is equal to 90 degree. Secant is not defined. At the value of x equals 90, we do not get a real number satisfying the secant function. Hence, here the curve and this line do not meet each other. Okay. Next, when x equals 180 degree, it is minus 1. It comes in below. So here, below the x-axis. So this is the point. And next again, so here these are the points. After joining all these points, we get like this. So after joining all these points, we get the shape of the secant x. We get the shape of the secant x. Again, you will observe that in the interval 0 to 2 pi, 0 to pi. See here, this is the graph of y equals secant x in the interval 2 pi. So again, in the interval 2 pi, the same curve repeats. So here, hence again we say that the secant function is also a periodic function. Secant function is also a periodic function in the interval 2 pi. Is it right? I hope you understood. Is it right? So here the white color curve represents the graph of y equals cos x, whereas the rose color curve represents the y equals secant x. So again we note that here cos function oscillating between -1 to 1. So therefore we notice that cos x is oscillating between -1 to 1, and it is a continuous curve. Next, whereas secant function lies beyond 1 and -1. So we say that secant x is greater than or equal to 1 and secant x is less than. Here, secant x lies beyond +1 and -1. Therefore, secant x is greater than or equal to 1 and secant x is less than or equal to -1. And this is discontinuous curve. Graphs of tan x and cot x. Here graphs are obtained joining the coordinates of a point satisfying corresponding equations y equals tan x and y equals cot x. So here when let us see the points, some points. When x equals 0, tan x is 0. When x equals 45, tan x y equals 1. When x equals 90, tan function is not defined. When x equals 135, tan is y equals -1. When x equals 180, y is 0. When x equals 270, it is not defined. When x is equal to 360 degree, y is not defined. And when x is equal to -90, it is -1. Okay. So let us see here. I have to draw the graph of y equals tan x. I consider coordinate plane. I mark the equal intervals of y by 2 on the x-axis and I mark the real numbers on the y-axis. So here the first point is when x equals 0, y equals 0. It turns 0, 0. This is pi by 2, 0, pi, 0, 3 pi by 2, 0. When x equals 45, approximately 45 comes here. When x equals 45, it is x, it is y, y is 1. Okay. Next, when x is equal to 90 degree, y is not defined. It means that for an angle 90 degree, a real number does not exist. Therefore, here we do not find a point on the exactly on the line of x is equal to pi by 2. So that is the meaning here. So after joining all these points, we get a curve like this in the interval 0 to pi by 2. Okay. Next, when we move to the 135 degree, 135 approximately comes here. When x equals 135, y equals -1. It comes here. When x is equal to 180 degree, that is again when x equals 180, that is 0. So here observe here after 90 degree and between the angle 90 to 180 degree, angles lies in the second quadrant. In the second quadrant, tan function negative. I mean that for any value of x, the quadrant and second quadrant angle gives negative. Therefore, the points lies below the x-axis. All the points for the angle greater than is in the third quadrant. In the third quadrant, tan is positive, means y is positive. Therefore, all the points lying above the x-axis. Okay. After joining all these points, we get the shape like this. So here, next, when I take it as minus a, when x equals minus 90, y gives minus 1, because if you measure the angle of OY dash in the anti-clockwise direction, it gives 270 degree. Is it right? When you measure the same angle in the clockwise direction, it refers minus 90 degree. Therefore, here tan of 270 degree equals tan of 270 degree is again not defined. Tan of is not defined. So here again it lies below the x-axis. Okay. So here in the interval minus pi by 2 to pi by 2, the shape of the tan is like this. Okay. Next, again in the next interval of pi, we get the same replica of the curve in the interval minus pi by 2 plus pi by 2. Therefore, we say that tan function is periodic function with the period pi. Okay. Similarly, when you observe the graph of y equals cot x, when x equals 0, it is not defined. Not defined means, so here the point do not, the y coordinate do not exist on the y axis. Next, when x is equal to 45 degree, approximately when it's 45 degree, it is 1. When x is equal to 90 degree, when x equals 90 degree, it is when x equals 90 degree, that is cot x is 0. So this is the point. Next, when x is equal to 135 degree, when x equals 135, approximate 135 comes here, it is minus 1. Here 135 second quadrant angle. In the second quadrant, again cot function negative. Therefore, the angles, for second quadrant angles, the corresponding y coordinate lies below the x-axis. After joining all these points, we get a shape like this. So this is the shape of y equals cot x. The same shape will be observed in the interval pi to 2 pi. So again here also we say cot function is periodic function in the period pi. Okay. So here, so this is the same shape will be get in the interval of pi. So here, this again is the shape of y equals cot x in the interval pi to 2 pi. It means that the shape of the curve y equals cot x repeats in the interval of pi. Therefore, we say that both tan x and cot x are periodic functions with the period pi. So that is tan pi plus x equals tan x and cot pi plus x equals cot x. Okay, I hope you got it. This is right. Here so far we have discussed graphs of trigonometric functions sin x, cos x, tan x, cot x, secant x and cosecant x.